Welcome to solverfy.
We first know from figure 3053C that the change in the thermal energy with respect to time is equaling 40 nanojoules per second. So we can essentially say 40 times 10 to the negative 9th joules per second. We can say that equation 2628, this is giving us that the thermal energy with the change in the thermal energy with respect to time is equaling the induced EMF squared divided by the resistance. We can find the EMF, the induced EMF in a single loop, so that would simply say N equals 1 for a single loop. And then using Faraday's law to find the EMF, this would simply be equal to the change in the magnetic flux with respect to time. This is equaling the area times the change in the magnitude of the magnetic field with respect to time. We then know that this is going to be equal to the area of the coil times the derivative with respect to time of the magnitude of the magnetic field, which in this case would be the magnetic permeability in a vacuum, times the N, the number of loops, and I, the current of the coil. This is essentially going to be equal to the area of the coil times mu naught N times the derivative, the change in the current of the coil, again with respect to time. Given this, if this is the EMF, we can then find the resistance. The resistance would then be equal to, again, the EMF squared divided by the change in thermal energy with respect to time. This is simply going to be equal to A of the coil, mu naught N times the, so mu naught is quantity. So mu naught times N times A, the area of the coil, times the change in the current of the coil with respect to time. This quantity would be squared multiplied by the change in the thermal energy with respect to time to the negative first. So essentially, we can then say that here the resistance would be equal to 4 pi times 10 to the negative 7th multiplied by N. Here, N would be equal to 8,000. So this would be 8,000 multiplied by the area of the coil, pi times 0.02 squared, multiplied by the change in the current of the coil with respect to time, 0.5 amperes per second. And then this entire quantity would be squared, multiplied by, again, 40 times 10 to the negative 9th joules per second to the negative first. And we find that the resistance here is going to be approximately 1.0 milliohm, or we can say 10 to the negative third ohm. This would equal the resistance. That is the end of the solution.